favor. This red expo is coming around. If you'd like, you can mark your homework. If you don't need to mark it if you don't want, because I will actually not collect today's homework today if you don't feel comfortable with it. What page was it? 47, 48? Okay. All right. I am looking at on page.
You know Hagen Rice here?
Yes.
He says no.
Let's take a look at numbers 1 through 9. I'm looking at 1 through 9 right now on page 47. Is there anything on 1 through 9 you'd like me to take a look at? Yeah.
Oh, wait. I have like a question in general.
Yeah.
Wait. No, it's not on these problems.
Okay, we'll get to your question. Yeah. Number 3, okay? So problem number 3, we're going to have 3x minus 4 and 2x plus 9. Okay, so this is double distribute. So I'm going to multiply here, here, and here, here. So I'm going to get 6x squared plus 27x. And then I'm going to multiply here and here, so I get negative 8x minus 36. Is that okay? Here's my like terms. So I have 6x squared comes down plus 19x minus 36. That's done. What else 1 through 9? Yeah. 7. All right, on this one, I'm going to distribute here and here, so that gets me x squared minus 2x. Then I'm going to distribute here and here, that gives me plus 5x minus 10. Is that okay so far? My like terms are negative 2x and 5x, so I can combine these together. So I'm going to get x squared plus 3x minus 10. Done. What else 1 through 9? Yeah. Nope, stretch. Okay, let me work number 9 real quick. Number 9, I have x minus 5 quantity squared plus 1. How many x minus 5s am I multiplying together? 2. So this should then now be written like this. Okay? Then you just double distribute here. Double distribute here. And don't forget the 1. Okay, so these are like terms, so I get x squared minus 10x, and then 25 plus 1 is 26. Anything else 1 through 9? Going twice. Sold to the boy who is using his glasses arm to pick his nose.
Glasses arm? Oh.
Just kidding.
Whoa, Joe, don't do that.
All right. Let me move on. So, taking a look at number 10. What are you guys doing?
He literally just walked.
He poured water on my seat and on my bag.
That's funny.
And then he knocked his seat out with my backpack, so I poured water on his backpack. And then he's like, no, you can stop.
I got boxing gloves out in the car if you want me to go get
And I
them.
was like, this is trying to slow down.
All right. All right, ready? So, I will break these down to their prime components. The prime component means I can't break it down any further. So I have to recognize that I can break 6 down to 2 times 3 and then times x. The minus comes along, yes? I need to also break 18 down to its prime component, so that's 2 times 9, and 9 is 3 times 3. Okay? So, of my 2 terms, figure it out, guys. Of my two terms, the 2, 3, and the x, and the 2, 3, and the 3, what do I have in common between those two?
Three.
I have a 2 and a 3. A 2 and a 3. Does everyone see that and agree?
Yeah.
So I'm going to factor that out. Well, I know that 2 times 3 is 6. What do I have left if I factor a 2 and a 3 out of that? X. The minus comes down. What do I have left if I factor out of there? 3. Done. Done. I factored it down. I broke it down. Number 11. I get 7x plus 14. I'm sorry I'm interrupting some of you. I can't break 7 down any further. But I can break 14 down to 2 times 7. Okay, so I have a 7 in common between the two. I have an x left here. The plus comes down. I have a 2 here. And we're done. Okay? May I move to the next board?
Wait, so I have a question.
Talk to me.
7 on the end.
It's because I have this and this the same,
It cancels
I
out.
pull it out front.
Okay.
I undistribute it. Okay, 12. All right, can I break 5 down any further? No, so I get 5x and x minus 6 breaks down to 2 times 3 times x. Of my two sets of terms, 5xx and 2, 3x, what do I have in common? I have an x. Okay, so I have a singleton x here and here. So that comes out front. What am I left with here? 5 and an x. The minus comes down. What am I left with here? 6. Done. I undistributed. Can I go to 13? Number 13. I have 12x squared plus 18x. Okay? 12 breaks down to 2 times 6, yes? 6 breaks down to 2 times 3. Then x times x plus 18 breaks down to 2 times 9. 9 breaks down to 3 times 3. And have the x. How do we look? Is that good so far? All right, so let me change colors, see what we can do. All right, I have a 2 and a 3, and I have a 2 and a 3. Do I have anything else in common between those two sets? The x and one of the x's. So 2 times 3 is 6, so that comes outside. The x comes outside. What do I have left here if I factor out the 6 and the x? I have a 2x. Cool. Plus comes down. And what do I have here? The 3. Done. It's factored. You have just undone factoring or distributing. Yeah. $14. Right? 14. I have 8x minus 12y. Let's break 8 up to 2 times 4. 4 breaks down to 2 times 2. And then I have an x. Minus 12 breaks down to 12 times 6. 6 breaks down to 2 times 3 times y. What do I have in common between the two sets?
2.
Just singleton 2? I have 2 2's. Good. 2 2. I have both those in common. Agree? Well, 2 times 2 is 4. What do I have left? What do I have left right here? 2x. The minus comes down. What do I have left here? 3y. There's my answer. I just undid the distributive property. $15. I have negative 4x plus 4xy. Okay. I have a negative. So I have negative 2 times 2 times x plus 2 times 2 times x times y. What do I have in common between the two? 2 2's and and x. I have those in common, and I have those in common. Agree? So that's the same thing as 4x. Agree? Okay, that negative needs to come down. Everything factored out. What number has to be a placeholder other than 0? 0 is never a placeholder. It is
Uno.
plus, what do I have left here? Problem's done. I just undistributed. 16 and 17, they get them into trinomials. Yeah.
Why doesn't the negative go in the
I could pull it out, but that would change this sign. That's something you'll see today. So right now you're good staying with just that. Okay. I didn't have a negative in common between the two. That's why I didn't pull it. Yeah.
So you would just, if there's not another negative, you would just bring the negative down, right?
Yeah, this negative came right here. 16, trinomial. Okay, let's go through it. 4 is 2 times 2. X squared is x. That's an x. Times an x. Let me undo that. And then 2 and x. That won't break down any. And then 10 breaks down to 2 times 5. Okay, so we have 3 sets of terms so far, right?
2.
So we have a 2 in common. Anything else?
X.
Is that an X there?
Oh.
No. But I like the enthusiasm. 2. What do I have left here?
2.
X squared. 2xx or 2x squared. What do I have here? X. What do I have here? Here's my answer. I undistributed that 2. $17. Again, I have a trinomial. So let's break it down to its parts. So 3 won't break down, so I get 3xx plus 2 times 3 times x plus 3 times 3. I have 3 terms. What do I have in common between the 3? What do I have in common between those 3 terms?
X and
Do I just have a 3? 3 here, here, and here. Do I have an x in common on all 3 of those terms?
yes. No.
Last term doesn't have an x, so I'm going to pull a 3 out. What do I have left here? X squared plus 2x plus 3. I just undistributed the 3 to all 3 terms. Okay, so again, some students will say, do I have to write it all out like that? Yeah. Until you get it down, please do. I'll give you time to do it. Okay, unfortunately, a lot of times students are, wow, I can do this in my head. I know. I've graded some of your stuff. It's not pretty sometimes. Yeah.
Why don't we put 3 like in the end where it's 3 times 3? Why don't we use both of those 3s?
Say that one more time. Why don't I do what?
Why don't we use both of the 3s at the end?
Because of the 3 sets of terms up there, they all shared a single 3. There wasn't double 3s on any of them. On all 3 of them. Okay? All right. Guys and girls, if you, bless you, if you feel comfortable handing in this because you feel really good about the backside, then you can hand it in today. If you're like, dude, you know what? I think I was doing it wrong. Let me take the opportunity to make it better. Then you can hand it in tomorrow for no deduction of points. Got it? So if you feel that yours is like absolutely perfect, you're like, dude, I got this, bring it on up. If you're like, hey, I'm like most kids, I goofed this up, I want to make it right, make sure the backside is correct. If you what here?
Bring it up here.
All right. Things good? But I should. One more. Thank you very much. All right, ladies and gentlemen, and all my friends, hello, please. All right. So, let's take a look at the warm-ups down at the bottom of the page. Oh, you need one more? Oh, I'm so sorry. I didn't mean to forget you.
Oh no, I'm sorry. I have two. That's not bad.
Oh, sweet. I can count again. Yay. All right. So, take a look at 1, 2, and 3. Try and factor it the way I had factored. Try it on your own, and I'll put the first step to it up here. So as you're working through it, if you're like, wait, how do these break down? I have the first factored step on each one. So as you're still working on it, take a look and see if I factor out what you would have factored out. Again. So that's what we've been working on, yes? Any questions on any of those? Yep.
On number
One.
you, multiply like the 2 times 2 and the 2 times 2 to bring it to the front, but on number 2 you multiply with the x's.
Because on the first 2 times 2 and the second 2 times 2, you shared actually 4 in common between the two. On the number 2, you just share a singleton x on each of them. Yeah.
So for the first one, I just did 4 times 4 times x minus 4 times 3 times y.
So you're starting to see it. I like it. And that works. So you should have the same answer as me then.
Yeah, I did. I'm
Good.
just wondering, is it
So you're starting to see it. So I'm breaking them down to the prime components, but you're going to start seeing the greatest common factors faster and faster. So good job, Joe. You're getting there.
more power to me? Great job.
You're up to an F minus plus plus minus
Yeah.
plus A minus
I actually have a D.
D. I'm just kidding.
Yeah, turn in my homework so I'm gonna have a D.
Don't ever threaten me with your homeworks. If I ever do my homework, I'll have a B in here. Yeah, whatever. I'm just kidding. All right, do we feel comfortable with those? May I move forward? All right. So the next one. So they're taking this term right here, and what they're doing is they're just replacing this and this with these binomials. Okay? Not because there's any math that's taking place. They just want to show you that you can have a binomial as a factor. So if I look at this problem that's now up there, notice I have x minus 3 and x minus 3, which are the exact same thing. So I can factor the binomial out. So I get x plus 3, still in parentheses. If I factor an x plus 3 out of this, what do I have left right here? The y. If I factor the x plus 3 out here, what do I still have left? The plus 2. Done.
Whoa.
You're pooping? Is that what you said? Oh. May I move to the next slide? All right. So, eyes up here. What do I have in common? What does it look like? Is this and this, do I have in common on both? Do I have that in common on both? Okay. So I'm going to factor that entire term out. So I have x minus 1 that I can factor out. I'm left with a 2x, that plus, and the 5. Done. Done. So I can factor out, the greatest common factor can be a binomial as well. Huh. What do you think?
That's tough.
All right, number 5, or my next slide. So I have, that's wrong color to use. I have that and that in common between the two, agree? So I'm going to factor an x plus 5 out of both. What do I have left if I factor an x plus 5 out?
3x.
A 3x
Negative.
and a minus 2. Done. Done. It's that simple.
That is simple.
Simply, simply, simply. How do you feel? Comfortable? So I'm going to make it real bad here. All right, what do I have in common between the two? 2x plus 3. If I factor 2x plus 3 out of the first one, I'm left with just an x. That minus comes along for the ride. Hey, wait a minute. What's my what? Yeah, there's a 1 that's sitting right there. Done. Chilling. Chilling out. So if everything factors out, you have to have the placeholder be 1. Life good?
Yo.
Very.
All right.
I mean, no.
This is where tears happen. I now have 4 terms. You still with me in this adventure of 4 terms?
X.
Okay.
Alright.
So I'm going to highlight the first 2 terms, and then I'm going to highlight with yellow the last 2 terms. Is that okay so far? Is that okay? So take a look at the very first 2 terms. What do I have in common between the first 2 terms?
X. Exponent.
Which exponent?
There's a plus in between.
Okay, so this is x, x, x plus x, x. What do I have in common between them? X squared. If I factor an x squared out of this, what do I have left? X plus, if I factor an x squared out of that, my placeholder is? 1. All right. Take a look here. That's 7 times x plus 7. What do you have in common here and here? 7, so plus 7. So that plus comes down. What do I have left when I factor that? Everything factored out from there, what's my placeholder? Pausing. I have blue and red parts of this problem now. What do you recognize between the two? You.
The parentheses are the same.
Yeah, the parentheses are the same. So that and that are the same. I can factor those out, yes? So there's one extra step sometimes. So I can factor an x plus 1 out. If I factor an x plus 1 out of this right here, what do I have left? X squared. And then I have a plus 7. Done.
Boom snap.
Yeah. Yeehaw. So someone asked me in the hallway, your last name's Stirrup, so you must be a cowboy. You're right. My horse is outside.
I parked it outside.
I will tell you there are people in the Stirrup family, that are extended family, that are ranchers, but I'm not that guy. Have I ridden a horse? Yeah, the ones that in front of the supermarket, you put a quarter in.
Those are fun.
Or if you're at the King Supers, you get the free one. You put the penny, there's a bunch of pennies on there.
Yeah, the people that leave the
That's the best. All right, sir, you've ridden this 16 times now. There's 4 kids waiting. I
I
know.
thought you kicked that if you multiple times for that.
I got yelled at.
The ones that keep trying to take supers for doing the Titanic thing on the shopping cart.
I like it. Are you all ready for the very last example? Here we go. All right. I have 4 terms. Agree? So, are you okay with that being factored down to that? It looks like I have a 2 and a 2 and an x and an x that I have in common. Agreed? So that means I have a 4x squared outside. I have an x left here, plus a 3 left there. I'm good so far. Everyone happy with that so far?
Wait, Mr. Stirrup?
Yeah, I haven't done.
A 3 on the 9?
There is. I haven't gotten there yet.
Oh.
I just did the 4x to the third plus 12x squared. So you look at the first 2 terms. Now I'm going to look here. Now, can everyone see that right there is a negative? So like almost always in math, and pretty much always in this class, if you have a negative there, that means you're going to factor out a negative. Okay, so if your third term is negative, every time in here means you're going to factor a negative out. All right, so let's take a look at this right here. So I have a negative 3 times x minus 3 times 3. Now what did I say factor out if you have that negative up there?
The negative.
Negative. So I'm going to factor a negative 3 out. Now hang on, put your pencils down and watch. If I factor a negative 3 out of that, what do I have left?
Negative 3 times 3.
Hang on, just right here. X. If I factor a negative out of this, what does this sign change to? Good. What do I have left? Does this kind of look like anything in common?
The parentheses are the same.
Good, the parentheses are the same, so let's highlight it, because I'm like all into the highlight stuff. Yay and yay. Those are the same, yes?
Yeah.
So I have x plus 3. Shh. Almost done. What do I have left? 4x squared minus 3. Good. So my friends, this is called something called factor by grouping. Okay, because if you have 4 terms that work this way, it shows that you can do this. I know you can do it. I love you guys for doing it. So your homework for tonight is 1, if you need to finish the rest of page 48, please do. But then you have page 49 and 50. 49 and 50. Hey, you. Guys and girls, I still want to point out that I'm available every day before school. If you want to come do your homework in my office with me.